So this was the input surface that we had. Okay. From this surface, just a surface, nothing else, no thickness, no nothing. So from this surface, we develop such a part. So developing a part from a surface is called A to B. Okay. That is creating a B surface and creating a C surface, which is this one, which is going to join the A and B. Some people are still coming. Just to discuss that from an A surface, what is the aesthetic surface you can say, or the class A surface, or the style surface. So all these are same. If anyone in your company, if anyone will say what is we got an A surface, we got an aesthetic surface, we got a style surface, we got a gas, everything means the same. Everything is just the same. So yeah, so this is the aesthetic surface, the A surface, or the class A surface, or the style surface, call it anything. So when you get this, then the next step is you are creating a part out of it. Okay. Once you have created a part out of it, now this part, imagine if like see, let us not let us not jump directly to features. Let us understand first. So now, so just I want everyone's concentration over here for a minute. So imagine that this is a part in your car, and like this is the armrest of your seat, something like this. This is a seat. This is a seat. Something. This is the headrest, and then here comes the next seat. Okay. And there will be the gear shifting knob, something like this. Will be the center console. This will be the IP. This is the steering. Okay, something like that. So now imagine this is the part. Now you can see the part which you have designed is somewhere here in the center console part. Okay, this is a part of the center console. So just when I sit here in the car, can I just keep it the part just in this way? If I have placed the part from above, I have kept it. Now, will it work? If I just place the part from above, I manufactured the part and I kept it from above. So, so will it work? Will it satisfy its purpose? So just think that if this is a part in a center console and if it is just placed from above, so whether it will serve its purpose, right? Or anything that is placed in the car, if it is just placed, it will fall off, right? If the car goes, if you keep what I want to say is, if the part is just placed in the car, it is not going to be working in that way, right? So we need to fix this part. Okay, we need to fix it. Everyone can understand, right? You can see this pic. Now, if there is an armrest beside it and I keep my hand over the armrest and it touches this part is going to move, right? Because there is a force acting on it. So it is going to move. So we need to fix this part. So for fixing the part, we need some fixations. And those fixations are called as engineering features. Am I clear? What is an engineering feature? I will be showing you how the engineering features are, how they are working, and what is their purpose and what kind of engineering features are there. But for now, I just want to print this sentence in your mind that engineering features are used for fixing the part. Very simple statement or very simple sentence. Engineering features are used for fixing a plastic part. Where it is fixing, how it is fixing, why it is fixing, when it is going to fix. Because when it comes in the assembly sequence, you cannot fix a part anywhere, anyhow, anytime. There is a proper assembly sequence for that. So when is also a question. So how the part is fixed, when the part is fixed, where the part is fixed, with whom the part is fixed. So all these questions we will answer slowly. Basically, the part needs to be fixed. Okay. So this is what is called as fixations. So engineering features are also called as fixations. Okay. Am I clear? Engineering features are also called as fixations. So what is a fixation? Now, when this part is there, I told you this is the aesthetic part. Aesthetic parts means I am going to see this part when I sit in the car or when I stand outside the car. Basically, this is an interior part. So when I sit inside the car, I am going to see this part. So that is called an aesthetic part. Now this aesthetic part has a B surface. That's why I am always turning the part. I am looking it from the inside. So this is the B surface. So which is not been able, like yesterday you learned. This is the surface of the part which you cannot see. It will be inside. So all the engineering features are always fixed on the B side or the inside of the part. Am I clear? Here again, no engineering features are fitted on the A side. Everything is done on the B side. Like I told you yesterday, A side, A part or A surface of a part or the aesthetic surface is never disturbed. It is kept as as it is. Okay, it is never disturbed. Okay, what all engineering features say, what all operations say, anything you need to do, you need to do on the B side. Okay, so this is basically the playground of a design engineer, you can say. B side is your playground. First, you need to create your playground, then you need to play over there. So, what is the game that you play? You play the game of fixation. That I want to fix this part. So, what is fixing? So, does anyone just a minute? Let us come here now. So, please tell me if you are aware of the term 3 to 1 principle. Anything?
Yes, I am aware of that.
Yeah, yeah. Okay. So yes, today what will see. So here you can see, uh, everyone can see my screen, right? I have just googled it, so not a big thing. You can also Google the same thing and read it for yourself. So 3 to 1 principle is also known as a method of fixing. So what the 3 to 1 principle does is it fixes a part. So a part always has degrees of freedom. Okay. So there are how many degrees of freedom? If anyone can tell me, unmute yourself and tell me.
6 degrees of freedom.
Yeah, right. So 6 degrees of freedom, we need to like restrict it, right? So when there is a degrees, so what is the 6 degrees of freedom? I will show you. You can see. So before going to that, first I will give you some simple definition. So this I think people may be knowing these things. So when there is 1 point, 2 point, and 3 point. So 3 point can make a plane. So if you need to make a plane, you need minimum 3 points. Okay. For making a plane, you need minimum 3 points. Okay. For making a line, you need minimum 2 points. Okay. To restrict an object into space, any space. Now consider this is an axis system. This is the space. To restrict this object in the space. Like, imagine this is an object. Okay. Imagine this is an object. So I want to restrict this object in this space. So I need minimum first 3 points, one plane. I need one plane. So I need one plane with 3 points. I need one plane with 3 points, one line with 2 points, and one point. Okay. So this is the minimum requirement. Now you go and study in detail how we can restrict a part using a plane, a line, and a point. Okay, I will like a plane will restrict what all degrees of freedom, a line will restrict what all degrees of freedom, and there will be only one rotational left. So one rotational, last rotational will be arrested by the single point. So basically, we need to arrest the degrees of freedom. So basically, any part which is placed in a space required minimum 3 points for a plane, minimum 2 points for a line, and 1 point to restrict all the 6 degrees of freedom. Am I clear here? You can see here. So 3 points for primary datum XYZ, 2 points for the secondary datum, and 1 point for the tertiary datum. So you will be learning what are the datums and basically how they are derived. So you can see this picture. See, these are the 6 degrees of freedom. Okay, you can see here. There is one transitional, one rotational, one transitional, one rotational, one transitional, one rotational, one transitional, one rotation. So basically 1, 2, 3 transitional and 1, 2, 3 rotational. That also plus and minus. Okay. So three transitional plus, three transitional minus, three rotational plus, three rotational minus. Okay. So clockwise, anti-clockwise. You can see here now. You can see this peak. It is a bit more clear. So these are the 3 points for line. These are the 2 points. So you can see this is the front view. This is the top view. So these are the 3 points for a plane. Here just you can see 1 point. So actually there are 2 points. The point is with there behind. So 2 points and 1 point. See here you can see in the top view there is 1 point, 2 points. So 3 point, 2 point, and 1 point. Now all the degrees of freedom for this block is restricted. Okay. So hope am I clear with the 3 to 1 principle? So this 3 to 1 principle is always used for the logic to fix a part. Okay, so basically now this part is having how many degrees of freedom, what is the assembly direction, how it is going to assemble, and all those things you will be considering and designing the fixation for it. Okay, now I will show you a part. Okay, you can see this part. See, so you can see this is a plastic part. This body is a plastic part. Okay, and the gray one is a BIW part. See, here is a BIW part. So what is a BIW part? You can say it is a structure of a car. Okay. This is just a piece of the BIW. So it is having hole, it is having cutouts basically. BIW is having cutouts. And this is the plastic part. So you can see there is some, like you can call it is a, you can say it is a door, something like a speaker grill or something. Basically, it is a plastic part. This plastic parts needs to be fixed on this BIW. Am I clear? Now, like we did A to B yesterday, you can see this plastic part is there. This is a closed surface, right? So A to B is done for this. You can see here now. You can see A to B, A plus B procedure. So styling surface is here. Okay. You can see the style surface is here. So if I hide this part, see, I have hidden this part now. So this is, I have hidden that part now. Now this is the style surface that you had received. So what input you receive from the customer is always the environment where the part is fixed and the style. Okay. So make a note of this, guys. Again, this is a very important thing. What all input you get from the customer, or you can say the client, or you can say the OEM. We get a style surface first of all, and we get the environment or the area or the adjacent parts on which the part is going to be fixed. So, like I showed you yesterday, this part which we did, okay, the part which I showed you for yesterday. So, this is the incomplete data because you have nothing. You cannot decide the fixation because you don't have the interference for it, or you don't have the adjacent part. So, basically, you don't know what kind of relation this part is sharing with another part. So, you cannot decide any fixation for this. But now, when you go to this part, you can see this is a complete input data. Okay, so there is an style surface. You can see this is the style surface. Then there is a BIW part. Okay, so this is the BIW part. So this plastic part is to be, this style surface is to be made to a plastic part, then it is to be fixed on this BIW part. So now your task is first to design the plastic part. So that is done over here. So we have made that part here. I've already made and kept it. Okay. Now what I will do is, for avoiding the confusion, I will just hide the style surface. So just to show you that what the input we got. Okay. So from that input, what I did is I generated a plastic part. Like it, I did A to B and A join, B join, C join. I got a part done, and now this part is thickened. Now it has thickness. Okay. So now what I need is I need to fix this part on this part. The plastic part needs to be fitted on the beard. So now what can I do? So you can see what I have on the BIW part. So there is a hole over here. There is a cutout over here. So these things I can. So basically, when we are having the input, you are getting to know what all things you can use for fixing. So they will tell you there are there are there are three circular holes and two rectangular slots on the BIW. They will show you that you need to fix this part over here. So now what you will do, you will start designing something so that the parts get fixed. So you can see that the design is in process. So now basically what I have done is I have made the dog houses here so that this part can be fixed on this part. So now here will be, here there will be some clip tower. See now how it is fixed. Now you see, so this is the Y direction. Okay, you can see when I'm clicking on the Y, you can see this part. Okay, so basically Y direction is the assembly direction. You can see it is going to be assembled in this direction, right? So this is the assembly direction. Okay, this is the Y direction. So basically, this is the plane on which the part is going to rest. So basically, we got 3 points already. This is the plane. 1, 2, 3 points. So we need 3 points in Y direction so that it can rest. Means you see, this is a surface and this part is resting on this surface. So this is the resting surface and this is the Y direction for our part. So imagine this is our part and this part is rested on this plane. So this plane is called as resting plane or the primary datum, which we saw here. Just a minute, I will show you. Okay. So here when you saw 3 points form the primary datum. So primary datum is the resting phase basically. So X direction. So this is the resting phase, the inside one. Okay. This is the resting plane. You can say now for our simplicity, I have taken this as a what we can say a straight plane. Basically, it is not always a straight plane. It is a, there are curves also. Then there is complex shape where you need to fix the plastic part. So this is a practice part you can say, or a simplified version for you to understand. So now what happens is now you need to fix this part over this BIW. So now I will be designing features so that I can place this part over this BIW. So what now? This is a doghouse. You can see here. I'll just hide this part now. This part is done. This is a doghouse. I have prepared here a doghouse which is already like you can see here. This doghouse, I need to add it in this. Okay. Let's see. Now what I will do is I'll define over here. You can see. Now you can see the doghouse is coming out. Then I designed those doghouse. So there is a design procedure how to design a doghouse. So basically show you basically this kind of rectangle is done. It is so this is the rectangle that I drew. Then I give a draft. Then I drew one more. I took one more body and I removed it from inside so it became hollow. Then I took one more body. Then I removed it from down. It is the coring. So all these things will be explained to you why coring is needed, what is coring. So I think the design consideration class for you is over. So rib to wall thickness should be maintained for avoiding the sink marks. Okay, so this coring is done. So after that, after giving the fillets, the final body looks something like this. Okay, so this doghouse is done. Then it is trimmed to this. Now you can see this doghouse is fixed on this plastic part. Now, why this doghouse? I will be explaining to you after some time. So basically, what I have done is wherever I need, because there is distance. Now you can see here. I'll just hide the part here. So then I will just measure. See from here on this surface to this surface. You can see there is 51 mm distance. Okay, the distance is 51 mm. So basically, your engineering feature cannot be that much, or cannot be of height of that much height. Okay. So now you can see the distance between the top surface of doghouse and the BIW. It is 10 to 11 mm, 12 mm basically. So this is a manageable distance. So manageable distance is like 15 to 20 mm max. If the distance is more, then you need to put a doghouse, and on that the feature will be mounted.